Okay, let's move on to case 3. So assume the last line is derived by means of conditional proof. There are two possibilities to consider. Either a single line was used in the application of conditional proof in order to get the last line, or two lines were used. So let's suppose first that a single line was used. In that case, what occurs on the last line is of the form if A, then A. Because if a single line was used, then we must have used the same line to get the antecedent of the conditional and the same line to get the consequent. Okay, but a simple truth table test will verify that a whiff of this form is true under all possible conditions. I haven't put the truth table up. You can do that yourself if you like. But a simple truth table test will verify that if A, then A is a tautology. So it's true under all possible conditions. So it trivially follows that if all the premises of our proof are true, what occurs on the last line is true. Of course, if what occurs on the last line is true under all possible conditions, then if the premises are true, what occurs on the last line is true. It doesn't matter in that case what the premises are. So that takes care of the first possibility here. So let's suppose then that the second of the above possibilities occurs. So the second possibility is that we use two lines. So suppose that is that two lines were used in the application of conditional proof. Well, since the last line of a proof cannot depend on any assumptions, all assumptions must have been discharged in this application of conditional proof. So it must be that what was inferred on the last line was a conditional of the form if A, then C, that one of the lines used in that application contained what corresponds to A as an assumption, and that the other line used contained what corresponds to C, and did not itself depend on any lines containing assumptions other than the line just referred to, the one that contains what corresponds to A. That is, in this case, it must be that the only assumption that was used and the only assumption which the lines that we use depend on is A, because all assumptions needed to have been discharged in this application of conditional proof so that the last line depends on no assumptions. So let's look at an example here just to get firmly in our minds what's going on at this part of the proof. So here is an example of a proof. We're supposing that n equals 2, and this is an n plus 1 proof, so it's a 3 applications of the inference rules proof. And you can see that it does have 3 applications of the inference rules, and the last line of the proof is gotten by way of conditional proof. So line 2 contains Q as an assumption, and line 4, which contains not P, that's the consequent of our conditional, depends on no lines other than line 2. So this is an example that illustrates what must be going on in this case. But if this is so, then there's another proof in our system which contains n or less applications of the inference rules, which is exactly like the proof that we are considering, except that the line containing what corresponds to C, the one we are using in our application of conditional proof in the proof we are considering, occurs as the last line, and the line containing what corresponds to A occurs as a premise rather than as an assumption. And perhaps also in that another line occurs in which A also appears as an assumption for previous applications of conditional proof. Okay, that's a mouthful, but let's go ahead and look at an example that illustrates what this paragraph says must be going on. So consider this proof. It contains 4 applications of the inference rules. And in this proof, P, which occurs on line 2, corresponds to A. And if P, then Q or R, which occurs on line 5, corresponds to C. Now, watch what I can do with this proof. I take this proof, and I take line 2 in the original proof, which was an assumption, and I turn it into a premise. And line 5 of the original proof, which contains C, has become line 6. And the reason it's become line 6 is on account of the fact that a line containing P as an assumption for the purposes of carrying out conditional proof was added on line 5. We had to add that assumption that occurs on line 5 in order to carry out the application of conditional proof that now occurs on line 6, because we turned the assumption on line 2 in the original proof into a premise, but conditional proof works with assumptions, not with premises. So we had to add this extra line, but by adding this extra line we didn't add any additional applications of inference rules, because the rule of assumption is not itself an inference rule. Now otherwise this proof is the same as the previous proof, except that it stops with the line containing what corresponds to C and contains 3 applications of the inference rules instead of 4. So this is another proof in our system that's like the previous proof, except that it contains n or less applications of the inference rules, and it stops with a line that contains what corresponds to C, and in this case it also has an additional line containing an assumption for the purposes of carrying out one of the conditional proof steps. Otherwise, though, this proof is the same as the previous proof, and we can always find a proof like this in a case in which the last line was derived by way of conditional proof. Okay, but now, given all this, given that we can always do this, it follows from the inductive hypothesis that if the premises of this other proof are true, the other proof that we can create in the way that I just suggested, then the conclusion of this proof, i.e. what corresponds to C, is true. Well, why is that? Because the inductive hypothesis tells us that any proof with n or less applications of the inference rules is such that if the premises are true, its conclusion is true. And we've just found that we can create another proof that has n or less applications of the inference rules with the same premises as our original proof, and that proof will be such that if its premises are true, its conclusion will be true. So it follows from the inductive hypothesis that a line containing what corresponds to C is validly derived from lines containing the premises of our proof in conjunction with a line containing A. Okay, but then, by what we've already proven concerning conditional proof, it follows that if the premises of the proof we are considering are true, what corresponds to if A then C is true. This is something that we've already proven concerning the nature of conditional proof, so we don't have to prove it again. So in any case, in either of the two possibilities for conditional proof that we've considered, it follows that what we infer on the last line by way of conditional proof is true if the premises of our proof are true. Okay, so that completes case 3. Now we can go ahead and wrap up the entire proof. It was a proof by cases, and we've now shown that in every possible case it follows that if the premises used in the proof we are considering are true, the conclusion of that proof, i.e. what occurs on its last line, is true. So since we made no special assumptions about the nature of the proof we are considering, since this proof was an arbitrary case, it follows by generalization from the arbitrary case that any correct proof in our system is such that if its premises are true, its conclusion is true. So it follows that our proof system is consistent. QED, we've now finished our proof of the fact that our proof system is consistent.